welcome to this video in the Math History unit. This is 2.11, where today we're going to be covering identification of significant figures and introduce you guys to rounding with significant figures, which, gotta say, are two more essential skills that we're going to use in chemistry class. If you haven't already done so, please make sure you have out your chemistry notebook and you take copious notes on what you're learning. And of course, to help you guys out, I have provided you a companion worksheet, so you will not have to write down a lot of the numbers that we see. You can just go right to the worksheet and do what you need to. So without any further ado, let's get going. So we talked a little bit in the measurement video about measuring to the proper number of significant figures, but we really didn't get into what a significant figure actually is. And by definition, significant figures are all the numbers in a reported measurement that carry meaning and contribute to that measurement. So here, if we look at this number that's there, you'll notice that we have some zeros, and then we have our first significant figure, our second, two more zeros, and then we got two more significant figures that we see here. So for a total of 6. I guess we got to get into what made these zeros significant, but yet these zeros not significant, and that's part of what we're going to be concentrating on in this video. To help set the stage for this, what you guys need to remember is that all measured numbers will always include some uncertainty. Remember that, like, we were able to make an estimate based on one place beyond what we were sure of with the measuring tool. So for instance, here I have 3 different rulers, and they are measuring the same piece of wood, and they are all, simulations of meter sticks. And if for some reason the number was reported out as 0.607068954 meters, none of those measuring tools could ever report this many digits or have that level of precision. So what we have to do is make sure that whatever the numbers that are reported are in fact significant and derived from proper measurement. And so we're going to start to get into how many numbers are indeed significant and figure out what numbers in a measurement like this we can actually drop. So let's dive in. We saw in this number that's right here that zeros present a slight problem, that sometimes they're significant and sometimes they are not. So they are going to represent some level of uncertainty in our measurements. Sometimes they're going to be placeholders, sometimes they are going to simply show magnitude, sometimes they're significant, and sometimes they are not. The zero is our problem child. Hello, Mr. Zero. To eliminate any uncertainty that you may have with how many numbers to report and how many numbers are significant, there have been rules that have been developed. Stop the video now, pause it, and copy these down, and then we're going to go through each one of these and explain what they mean. All right, let's start with rule number 1. Rule number 1 says, because zeros provide some level of uncertainty in a reported measurement, that any numbers that are non-zero numbers are considered significant figures. So if we saw the number 847,565 and we said, how many significant figures are there in this measurement? Well, we would say that there's 6, because all non-zero numbers are significant. This is your first sig fig, your second, your third, your fourth, your fifth, and your sixth significant figure. Zeros become significant when they are what we refer to as sandwich zeros. Sandwich zeros are usually sandwiched in between two non-zero numbers. And so, like, the non-zero numbers are kind of like the bread, and this is the meat that's sort of right there. And we'll notice that because this zero is sandwiched between two non-zero numbers and that zero is sandwiched between two non-zero numbers, both of those zeros are considered significant figures. So if we said, how many sig figs are there in 2,407,605, we would say there's 1, 2, 3, 4, 5, 6, 7 significant figures. Let's look at zeros that come after a decimal. These are what we call trailing zeros. Trailing zeros after a decimal are also significant. So in a measurement like this, what we're going to see is there are 6 significant figures: your first, your second, your third, your fourth, your fifth, and your sixth sig fig. Do not confuse those with the zeros that appear at the beginning of a number, decimal point or not. These are what we refer to as leading zeros. They are not significant, they do not contribute to the measurement, and they are simply placeholders. So if I look here, my first significant figure would be this 8, and my second would be the 6, for a total of 2 significant figures that are there. Compare that with the number like 5800, where we have zeros coming at the end. These are trailing zeros, but they're not coming after a decimal point like this one did that was over there. Trailing zeros without a decimal are also placeholders, show magnitude, and the rightmost non-zero number, which would be your 8 that's here, is your last sig fig. These guys are not considered significant. So we really have our first sig fig, our second, for a total of 2. If for some reason, and this is a special case, someone wrote 5800 and then reported it with a decimal that's here, that means they were confident and their measuring tool was able to measure it out to this ones place that is here, and that decimal point that's there renders all of these digits significant. So this would be your first, your second, your third, and your fourth sig fig. So the decimal point is magic. The decimal point will always render anything that is to the left of it significant when you are dealing with a large integer like 5800. Okay, what I'd like to do now is throw some numbers at you and see if you can identify how many significant figures in each of these values and what rule it's based on. And to help you, I'm going to walk you through this. So this is almost guided practice to help you through understanding significant figures. So pause the video now and try to figure out how many significant figures in each one of these. Unpause, and I'll put up the answers and walk you through it. Okay, let's take a look at all of these and see how you guys did. In this first example, 3 digits, 4, 5, 8. We have a total of 3 significant figures here, all of them non-zero numbers. All of them are significant. Your first, your second, and your third sig fig. In the second example, we have leading zeros. Well, we know leading zeros are not significant. So the first significant figure is the first non-zero number that shows up after your leading zero. Your first, your second, your third, for a total of 3 significant figures. Here I have a 0 that is wedged in between 2 non-zero numbers, which we refer to as sandwich zeros. That makes that significant. So there's your first sig fig, your second, your third, and your fourth, for a total of 4 sig figs. Here I have a number that has a trailing 0 but no decimal point. So what do we know about that? That guy is not significant. So there's a total of 3 significant figures that are here. Here we have leading zeros again and a sandwich 0. These guys not significant, but this sandwich 0 is, so we have a total of 4 significant figures here. This is your first, your second, your third, and your fourth. And of course, in a number like this, we got a bunch of sandwich zeros that are there, so that means that they are all significant because they are wedged between non-zero numbers. We got a total of 8 significant figures. Your first, your second, your third, your fourth, fifth, sixth, seventh, and your eighth. So now it is time to take the training wheels off. Your turn to see how much you now know about identifying the number of significant figures in a measurement. Pause the video now, try these, and then unpause when you're ready for the answers. All right, if you did this correctly, here's what you should have gotten. Make sure that if you had any uncertainty or any questions on this, that you note what your question is, and you certainly bring it up when we wind up reconvening in class tomorrow. Now, there are 2 special cases of significant figures, and they come when you're dealing with scientific notation and exact numbers, counting constants, and conversion factors. So the goal is going to be to figure out how many sig figs in each of these cases that we see here. Let's go to the videotape and check out scientific notation first. So in scientific notation, you guys should know at this point that it always consists of a coefficient, a base, and the exponent. Well, the rules for sig figs are as follows. All the numbers that are in a coefficient in scientific notation are considered significant. So these 3 numbers, no matter what they are, whether there's zeros that are here or anything, are considered sig figs. We would have 3 significant figures in this value. It does not matter that there's an exponent of 34. Don't tell me that there's 37 significant figures because of this. No. It's only what is in the coefficient. So don't be that guy and ever get that wrong. Make sure you tuck that in your pocket for later. So if we look at this, we know that the coefficient in scientific notation is always significant. Doesn't matter that this value is less than 1. We got a negative exponent. These numbers are all significant that are here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 significant figures in this measurement. Moving on, we're going to now talk about exact numbers, when you count things, constants, and conversion factors. The rule for significant figures is that anytime you have these exact numbers, any constants, conversion factors, they are all considered significant. And I'll tell you a little bit more. Examples of exact numbers or counting, for instance, are when you would say, well, how many kids in this classroom? Well, you could certainly count them and leave no uncertainty to get a total of how many kids are in the room. How many cats are in a hoarder's house? How many cupcakes are in the bakery? How many chairs are set for a table? How many forks there are? Anything that you can count without uncertainty is considered to have what we call infinity or infinite sig figs. That is the sign for infinity. Other things that have infinite sig figs that leave no doubt as to their value. Pi, 3.14. The speed of light, right? 3.0 times 10 to the 8 meters per second. Avogadro's number, which is 6.02 times 10 to the 23rd. That's going to be super meaningful later, but you don't know what it is at this point in the year. But because that is a constant and is a number that leaves no uncertainty, that has infinity sig figs. Same with conversion factors. Like if you were saying that 5,280 feet equals 1 mile, that whole sequence of digits has infinite sig figs. How many quarters in a dollar? Well, we know that there's 4 quarters in a dollar. No uncertainty. How many centimeters per inch? 2.54. We know with no uncertainty. So they all have infinity sig figs. Part 2 of this lesson is going to revolve around rounding. And yes, I am going to be teaching you rounding, and I know that you all learned rounding back in the day in elementary school, but there is now a piece of the significant figure lesson that deals with being able to take numbers and round them to a certain number of significant figures. So the skill that you have to use in order to do this is exactly what you learned in elementary school. Here is a poem all about rounding. I remember my teacher taught this to me. He said, find your number, look next door, 5 or higher, add 1 more, 4 or less, just ignore. And so what that really means, if you really skipped rounding and never got there, like let's say I wanted to round this to the 10th place. Well, here's my 10th place number. I have to look to the number to the right of it because it's a 5. I am going to add 1 more and drop this digit that's there, and that gives me 13.7. So rounding with sig figs in chemistry is quite similar. It is essentially a procedure of dropping non-significant digits in a reported value and then adjusting whatever that numerical value is to match a desired number of significant figures. And as you're going to see, sometimes you have to drop numbers, sometimes you're going to have to add zeros, you're going to have to do all kinds of different stuff to make it work, but that is what this lesson is all about, so I'm happy to take you through it. So let's play. I'm going to give you guys some examples, and you're going to use the general mechanics of rounding that you know, but now we are going to implement the significant figure twist into it. Let's just dive right in. Let's say you get a number like 45.462, and we want to round that to 4 significant figures. Well, first thing we got to do is say how many significant figures overall in this number. And from the earlier part of this lesson, you know that there are 5 significant figures that we are looking at. So the key to round it to 4 is to find the 4th significant figure. Here's the 1st, 2nd, 3rd, and 4th. So now we implement the mechanics of rounding that we know from elementary school, right? Find the number you want to round to, look next door. We're going to go look at that 2 that's there, right? And because it is a 2, remember 5 or more, we will add 1 more to that number. 4 or less, we're going to ignore. And when we say ignore, what we have to do now is we're not going to ignore this and leave it there. Otherwise, our answer would be still to 5 significant figures. What we're going to do now is actually drop that value. We're going to drop it and get 45.46, and that will give us 4 significant figures. And the important thing that we need to remember is that whenever we are rounding, no matter what it is, the magnitude of the number that we turn the pre-existing number into has to essentially match. And the way I always think of it is like in terms of money. If somebody owed you $45 and 46 and 2/10 of a cent, if they paid you $45.46, you know, I think you'd be okay with that. It wouldn't matter that 2/10 of a cent. They are pretty much the same number. So I am keeping the magnitude of the value that I rounded it into. Let's try the next one. Here it says I have same number, 45.462. It's rounded to 3 sig figs. So we got to find our third significant figure. That is your first, your second, your third. So that is the number we want to round to right there. We got to look next door. It's a 6. So because it's 5 or higher, I'm going to add one more to that number that's there. I'm going to get 45.5. And I have retained the approximate magnitude of what I have, so I know I did the right thing there. Now we're going to round this to 2 significant figures. So the first thing we got to do is find our second significant figure that we wish to round to. Here's my first, there's my second, so that's the number. I'm going to look next door, and I'm going to see what we got here. That's a 4, so I'm going to ignore, but I'm not going to ignore it and just leave it. Otherwise, I would only have 3 sig figs when I'm shooting for 2. I am going to drop this number, drop the 6, and drop the 2 and give me 45, which would be to 2 significant figures. And as you can imagine here, I am going to round to 1 significant figure. Here's my first significant figure. That's the place that I want to round to. I look at the 5. The 5 tells me I have to add one more to that. To 1 significant figure, my answer actually turns into 50. And you're probably sitting along at home going, well, 50 is not 45. Like, you just radically changed that number. But believe it or not, it is okay. Because as you are going to find when we dive into our next video, which is all about how to do calculations, that the answer that you get can only be as good as the numbers that go into it. When we talk about good, we're talking about the level of precision and how many decimal places in many cases these numbers go out to. So because we wanted only 1 significant figure, our answer has to match the quality of that. 1 sig fig is not great in the science world. You really want to go for 4 or something like that. That's really where it's usually at. You can get away with 3, and 2 is 1, definitely no bueno. All right, it is your turn to practice. So let's take all of these values that we see here and round them all to 4 significant figures. So you are going to use the skills of identifying how many sig figs are here, finding the 4th significant figure, looking at the number to the right of it, and then rounding accordingly. You may have to add numbers, you may have to drop numbers, but do whatever you got to do to round them to 4 sig figs. Pause the video now and then unpause when you are ready for the answers. Okay, here we see our answers are in purple. If you did this correctly, you should have gotten all of these things to 4 significant figures. That means you had to first identify how many sig figs are in the original number, figure out where your 4th sig fig was, and then apply the rules of rounding. So make a note if you got anything wrong, and of course we can certainly bring that up in the burning questions segment tomorrow, which I'm sure will be hot like Mustafar is. And that's pretty much it for me for this lesson. It has been a pleasure taking you guys through significant figures and rounding. Tomorrow's lesson gets a little more crazy when we start to do calculations. But for now, that's it for me. Peace out.
That's all, folks.